What's going on, friends of Rottler? Ryan Thompson back with another product overview here at Rottler. Today we're talking cylinder heads, specifically seats, cutting seats and reaming guides. Behind me is our SG9MTS machine. This is our, well, it's really a cylinder head seat and guide machine targeted for job shops, performance engine builders, and even production shops. It's a semi-automated machine. It features our Manualmatic software, which allows you to preset the depths or the heights for the pilot to lock, unlock, spindle to turn on and off, which allows, once those things are set, as the operator, we can simply go down the line here and the machine takes care of itself. All we do is keep our hands on that steering wheel and watch the machine as we see our DRO get to the correct positions. The Rottler seat and guide machines feature our patented Uni-Pilot tooling system. Our pilots are straight through the first about 2/3 of the bottom section, and then they taper the last inch by about 7/10 of an inch there on diameter. This allows us to cut like a fixed pilot system, where the tool is actually going to spin on top of the pilot. All of our pilots are carbide and precision honed to the exact size that we need them to be. The taper registers in the guide, the tool spins on top, but what's unique about Uni-Pilot is it has some grooves that we'll bring in here and show that allow this to lock in to our tools, and that allows you to go hole to hole with a single pilot. This is what gives us some of that automation. So we've got some demonstration here. I've got a brand new small block Chevy head from Dart, and this is a very beautiful piece that they've done here. And for a fact, I know these seats are actually pretty good right now, but we're gonna make them even better. And I've also got an LS cutaway here that we're going to show you just how this system kind of works, give you a thought and feel for it. And then we'll hop onto the machine here and show you exactly how we set up, write a program, and then cut all of these seats in our automated method. So on our Rottler tooling system, it consists of a couple parts here. We have our tool bodies, which include the insert holder, which holds our form tool, our form insert. These inserts can be made in any set of angles. Today I've got a full radius with 2 top angles as well as a 5 angle. We make single, 3 angle, as well as full radius and 5 angles. Our tool body itself, which holds the pilot, and this is part of our Uni-Pilot system, has this locking collar. And this is what's going to hold our pilot. So as we talked about the pilots, this first section, we've got a 8.7 millimeter pilot here. And through this first 2/3 of the lower portion here, this is going to be straight. And we want to make sure that when we fit this to our guides, that we're getting the tightest possible fit. Okay, and the tapered section here is going to register on the top of our guide, but we want to make sure that we're as close as possible, and that's what ensures the best concentricity when we're cutting seats. Our tool, our pilot here on the back side, has a ground notch in it, and this ground relieved section here is what allows our tool body to slide over, and there's a set of springs with some engagement teeth in here that lock this in. Now this collar, when it's up and out of the way, allows the pilot to move in and out freely. When we lock our collar down, this is going to engage those teeth, so we can't pull this pilot out. And this is what allows this system to go hole to hole. There's a spring in the back here. This is your bounce spring, and that pushes the pilot down into the guide during cutting. On this LS here, I've got an 8 millimeter pilot. So just to show, if we look at this cutaway, this is going to slide in here, and we want this to register on that taper here. And this is about right. Now there's a range here, and there is a guide that comes with the machine to tell you if you've got too much sticking out the top. But what we always want to check with our pilots is we want to make sure we have a nice tight fit in here. If you've got any rocking or slop, then that's going to lead to a concentricity issue. The tool right? In the cutting operation here, this is going to slide over the top, and in the cutting mode, this would be, the spring will push the pilot down into the guide until it's registered, and then the tool is free to travel on top of this pilot, cut the seat, and when we move hole to hole, those drive dogs are going to pull the pilot back out of the guide. We have a few options for setting our cutters here. The standard is our DSP, and this is just a little needle gauge. What you do with this is you can put it, let me do the intake here. You can slide this over and clamp with this little detent set screw. It's got a spring on it, and set this right at the edge of your valve 45, okay? And this allows you, you want to be 10, 15 thousandths back for your setback. Just a quick way to set this. And what we can do is we can lock this into position on the valve. And we can take this and then transfer over to our pilot when it's in our tool body. And one of the nice things with that spring, we can then push this in and find the top edge of our 45, since that's our seat angle today. Find the top edge, and we can adjust with this set screw by unlocking the two screws that hold the tip holder in, and there's a set screw that lets this travel in and out. This allows us to quickly set our cutters. We also offer a boring micrometer, which allows you to put the tool body itself into a setting fixture if you want to set to an exact diameter. Very popular with engine builders and performance. Okay, so we're over here at the machine now, and we're going to get our head loaded in here, talk about the machine, and show you just how easy it is to set up and touch off of a seat and save those values to store in our Manualmatic software. A couple key points here. We're using our manual rollover fixture. This is a 360-degree rollover, which means we've got two precision machined locating surfaces here. We load the cylinder head upside down. So we're referencing the fire deck surface, and then we flip the entire head over in the fixture to reference our deck height. We've got these backstops here at the back of the fixture that reference off of the manifold surface. And this allows us that when we roll over, we're cutting equal seat depth by design with the fixture. The other nice thing about this fixture is because it's 360 degrees and this machine also has tapping cycles, we have the ability to cut seat pockets, we can ream in this, we can tap holes, kind of do all that other peripheral work around the cylinder head. It doesn't just have to be cutting seats. So let's get this head loaded in. Like I said, fire deck side down. And what we're using here today is these little locator wedges. They're just clamps. They slide in here to some holes on the fixture, and it's got a dowel in it. And what this allows it to do is to clamp wedge type heads. And all we want to do when we're setting these up is we just want to look and make sure that we've got about even and clearance on each side. And then we can tighten down our thumb screws to clamp this cylinder head in space. Now, it's always a good idea, I've got this locked on the right side, when you're clamping, to make sure you don't get any binding or mismatched angles in your fixture, go ahead and leave one side loose, and that'll let everything kind of settle in. We take a 10mm wrench, and we'll just put a little tension on these. Then we're going to go ahead and roll this over. So we'll loosen up both sides and present the seats. Now we'll just eyeball up and down. And then what we can do is we'll take our pilot. We're using a 8.7 again today. And we're just going to stick this. Now it's always a good idea to make sure this fits. Sometimes you have, especially with used cylinder heads, you can have some inaccuracies or repeatability issues with guides. One's worn out more than the other. So it's always a good idea to make sure that this is going to be a pilot that works for all your guides. Once we get make sure everything's looking good, we'll go ahead, we're going to stick this in any one of our guides here. We'll just pick one in the center. And then we've got our angle sensor attached right here on the machine. Now this is sitting on a post here, and this post comes from the factory. It's dialed in to reference our spindle. So we sweep this in both axes to make sure that it's referencing and it's parallel with our spindle. And what we want to do is we want to take our angle sensor, drop it down on our pilot, and we just want to take a look here, and we're going to get this so where the angle sensor reads 0, front to back. And I can loosen up my fixture. I can use my hands to get it close first. We'll just kick this over. A couple taps. Get it within 1/2 degree. And then this top knob on the right side of the fixture, this engages my fine feed. So there's a lead screw down here that'll allow me to finely adjust. So I want to engage that by tightening this. And then what I'm going to do here is I always want to go past to take the backlash out of this system. And I'll come back and I'm just going to come to 0. Once we're at 0, tighten down our fixture clamps. Make sure everything's settled. And now what I'm going to do is I'm going to go ahead and check my left to right. Now on this machine, we don't tilt the cylinder head at all. These levers here, there's one on the left and one on the right. This engages a cam inside the work head, and this handle allows me to cant my work head. This allows me to match whatever angle these guides are at, as well as if I'm working on canted valves, such as a big block Chevy, I can kick this over to whatever angle I need for canted valve work and be able to match my guides. So I've got about 0.05 degrees here in the negative direction. I'm going to take my angle sensor and rest it back here on my post. And now I'm just going to adjust my work head until it reads the same number. Tighten down my clamps. And now we've got a setup cylinder head. So our pilot should now be matching our spindle in the same axis. What we want to do from here, I've got my whole control, and from the main page I have a manual mode and a Manualmatic mode. If I'm just cutting one seat at a time, or I just want to do a setup, the manual mode lets me manually turn the spindle on and off, cut one seat, and set my DRO for my height. This machine, you've got the hand wheel, a fine adjust, a hard stop, and then behind here on the right, there's a linear scale. That linear scale is tracking the spindle. So if I hop into my manual mode, and I've got touchscreen controls, where I can manually activate my float. And what I want to do here is I just want to put my tool, we'll start with intake here, tool and pilot, and I want to get it loaded into the spindle. Now this has a quick clamping nut. All I need to do is get the drive dogs to engage, and this automatically clamps. Now what I like to do is just rotate the spindle with my hand in the tightening direction. If you get on this and you over tighten it, what happens is during the cutting operation, this nut actually tightens up. Not a big issue, but if you put too much on this, when you go to take this out, you'll have to use the spanner wrench to loosen this, and it just doesn't need that much, so you just give it a little bit. And now the Uni-Pilot system, you can see right now this is able to kind of act like a U-joint. And what we've done at Rottler with the Uni-Pilot is the pilot is one part of it. The second part is actually inside the spindle. So inside the bottom of our spindle here we have what's called our sphere. And the sphere is a precision ground sphere, and it acts like a U-joint. I have the ability to control this. This is actuated with a pneumatic cylinder that activates a tie rod through the spindle. In the unlocked position, that's going to be for when I'm actually in the cut. That allows the cutter to follow the guide or follow the pilot. when I'm floating the workhead and centering on the guide, I'm going to want to have this in the locked position. Now, having this tied to the pneumatic cylinder, when I'm in the Manualmatic software, it's going to do this automatically for me. So I just need to manually do it to set up everything here the first time. Once I save all my values, this is done automatically as I go hole to hole. So I'll put my pilot back in. We also have some lamps here we can turn on. I'll make sure this is engaged in with the holder. And now what I want to do is for the best cutting here, I always want to make sure that my work head isn't overhanging. It should be about centered of its travel. So I can put my thumb here, and where the edge of this top of the casting is, this top float surface, and the base plate for the workhead, I just want to make sure those are about even. And then I can float my cylinder head back in its fixture here, and just make sure I'm about centered and even. Once I'm close, I can reclamp my fixture and lock it back down. So what I'm going to do is I'm going to float my workhead. I've got my pilot locked, and I'm going to come down just until I see the pilot stop moving into the guide. That means it's registered on that taper, okay? And at that point, that's the position where the tool is riding up and down on the top of the pilot. So at that point, I'm free to lock my workhead. That locks this to the casting, and I'm going to unlock the pilot. So now I'm in my cutting mode. Up above here, I have spindle RPM and finish RPM. I can switch between each one of those. For just cutting, I can run on the spindle RPM. When I want to finish and dwell, I can switch to my finish. I'm running at 120 RPM on my cutting RPM and 70 for my finish right now. And what I'm going to do here is I just want to come down until I see this seat fully clean up. And up above here, I've got vertical 0 with a set button and my vertical position. Once I've seen it clean up, I'm going to set that as my 0. So I'll turn my spindle on. Once I get close, I can switch to my finish RPM. And while I'm here, I'm going to set my hard stop. And I'm just going to let this spark out. And while I'm here, I'll press set 0. That's zeroed out my vertical position. And I can retract back out. I'll turn the spindle off. So now we've got all of our angles all cut into that seat. Our profile's been cut. And now what I want to do is I want to take what I just did there and write the Manualmatic program. So if I look up here at the top, I have options for exhaust, manual, tap, ream, drill, and intake. I'm going to select intake. This will take me to my Manualmatic. Now, this is referencing the vertical position I already set. And right now, I'm in the setup mode. That lets me program my finish depth, my centering and my start height, my retract height, and my float height. The way I like to program this is I work from the bottom to top, and there's these set buttons on the side. So what I'm going to do, I've still got control of the machine from over here. I'm going to float back down. Now, my finish depth is going to be 0. Now, this finish depth, when it hits this point, it's going to automatically turn to the finish RPM. So what I usually like to do is I can type in on the box here, and I usually type in something like 2,000ths. So what this is going to do is when it gets to 2,000ths on the DRO, it will automatically switch, and then I can watch my DRO until I'm down at 0. And I have my hard stop set to make sure I don't go past. My centering height, or my start height, this is where the spindle is going to turn on. And where I always want to set this is that position we found earlier where the pilot is registered on its taper in the guide, and my tool is moving up and down on the pilot post itself. So I just come in here, and that looks about good. I'll press set. My retract height, I can set this anywhere. Usually a good point is just where the tip of the pilot is out of the guide, really anywhere just above. This is where it's going to start floating the workhead again after you've come up out of the seat. And then my float height, this is when it's in between the retract height and the float height, the workhead's going to be able to just float around automatically. What I like to do with this is you can use this as kind of a park position. So I usually just go to the top of my spindle travel and come down, just a 1/16 of a turn on the wheel and press set. What this is going to let me do is I can take my pilot out and float the workhead all the way over, and then as an operator I can just run this to the hard stop all the way retracted, and it'll just park it over there. If I'm batching heads and I just want to load the next one, that gives me a nice area to just sit for a little bit. So what we're going to do here now is that's it. We've wrote our program. We can type in our spindle RPMs again. Let's do 150 on the RPM, and it was finishing pretty good at 70, so we'll just run that again. And this is how easy it is. This is programmed for the Manualmatic mode now. So we'll go down here. What we're going to do is I'm going to do the same thing on the exhaust seat. I'll do that off camera, and then we'll bring the camera in and we'll just cut both. We'll just take everything down the line, swap both of them so you can see everything in action and just how easy this is. Okay, so I'm going to go ahead here now and just turn on the Manualmatic. I'm in my intake program. I turn it on, and now the machine is in control. So as soon as I get below, the lights are going to flash every time I'm at one of those heights that we programmed. So all I got to do is keep my hand on this hand wheel. Once we get to our start height here, the machine automatically locks. It's going to turn the spindle on. Automatically switches to its final. Let it spark. Retract back out. Intakes are done. So like I said earlier, I can take my pilot out, float my workhead to the side, put it in its park position. We'll change these pilots. We'll do the exhaust. So I've got the intakes done now. Let's swap out the tool. We'll run back across our exhaust. To do that, release the quick nut. Put my exhaust in here. And now I'm going to switch over to my exhaust profile. I'll turn this to on. I'm going to move over here. We'll go left to right again. We already cut this first one and wrote our exhaust program. So we're going to move over to our second. Pause and install our pilot. And we are ready to go. So same thing as before. Make sure your guide's clear. Come down. It's going to automatically lock. And that completes our exhaust. I'll pull the pilot. Set this to park position. And now I'm ready to flip this over, unload the head, and load the next one. Fast, easy, efficient. This is the SG9MTS with Manualmatic software, allowing you to do more, quicker, and get after it. We'll catch you next time. I'm Ryan at the Applications Department here. Hope you enjoyed this. Give us a shout at RottlerMFG.com. You can email me direct, Ryan@RottlerMFG.com. Happy to help you out with any cylinder head, seat cutting, block work, whatever it is you guys are doing. Give us a holler. We're here to help. Take care.